Hello dear viewer, thank you for streaming live on our YouTube channel. Again, I'm Joseph Sebuato, a teacher at Namugongo Secondary and Vocational School, and I'm here to take you through pressure, the topic in physics. Last time we discussed pressure, and we saw that pressure is the force acting normally per unit cross-sectional area. We discovered that pressure acts on, there are two factors on which pressure depends on in solids. We said one, it depends on the force being applied on the object on the surface. Then in two, we said that it depends on the cross-sectional area. We saw that the area on which the force is being applied determines the nature of the pressure you are getting. You can obtain a maximum pressure or you can obtain a minimum pressure. We saw that to get a maximum pressure, you should be having the smallest area. You can even say smallest area. Smallest area. It can give us a maximum pressure. Also, for us to get a minimum pressure, we can get the force acting divided by the biggest area. So these two things here are in play, and they are the ones that can determine the maximum or the minimum pressure. I told you, I gave you some examples on things at home that where maximum and minimum pressure is applied. Actually, if you go to dams of water, dams of electricity, you find that the walls down there are made thick. They are very thick and very big, such that they can handle the maximum pressure that is down there on the water, because you find that the pressure at the bottom is greater than the pressure at the top. We shall look at that under liquid pressure. So today we want to look at how to calculate calculation of minimum and maximum pressure. So long as we know the weight or the force acting, and we also know the size of the object on which it is being acted on. For example, it can be a box, as an example down there you are seeing. In this example, we have a box. This box can be a brick, can be anything. But this box here, they are saying that the box weighs 60 newtons, and they're telling us to determine the maximum and the minimum pressure it exerts on the ground. Now, as a physics student in this class, they have given us the weight of the box. Now, the weight can be the same as the force, which is 60 newtons, as stated in the question. Now, the dimensions of our box, when we talk about the dimension, we have the length, we have the width, and the height, because this is a three-dimensional figure. So, the length is 3 meters, the width is 2 meters, and the height is 1 meter. Now, the question is saying we determine the maximum and the minimum. Now remember from our formula that pressure maximum is given by force over smallest area. Now for us to calculate the area here, we are going to determine, we are going to get two sides of this box. Remember, area is obtained by, area is given by length times width. Any two sides. Can be length times the height, can be width times the height, anything. So long as there are two sides of the box, we can obtain the area. But the area we are obtaining, it can either be the biggest area or it can be a smaller area. So for us to get maximum pressure, we need to get the smallest area here. And the smallest area, we take two values that give us the smallest answer. For example, we have 1 meter, we have 2 meters, and 3. You can see that if I multiply 1 times 2, I'm going to get 2 square meters. That's the area. Or another one can say, I can also get the area by getting which is 3 times 2. I can still get 6 square meters. Now the question is, on these two answers, which one is bigger than the other? I think you have seen it. 6 is bigger than 2. So this one here can be our smallest area. And this one here can be our biggest area. So, for us to determine the maximum pressure, Pmax, we have said we get the force and divide it by the smallest area. So the force is 60 and our smallest area here is 2 square meters. Now the answer you're seeing here is the 30 newtons per square meter. Remember, force is in newtons and area is in square meters. So the unit here for our answer is going to be 30 newtons per square meter. Or another one can write it as 30 pascals, no problem. Because we saw in our introduction that 1 pascal is equivalent to 1 newton per square meter. So here is our maximum, 30 pascals. Now what about minimum? So for us to get minimum, for us to get the minimum pressure, we are going to look at the biggest area. So our pressure minimum is going to be still the force divided by our largest or biggest area. But from here, the force remains the same. As I told you, you are not supposed to change the weight because it's the same box. So it exerts the same weight on the ground. So if you are trying out these questions on maximum and minimum, make sure that the force is the same. Because if the force is not the same, you don't get the same answers. So the force here is the same, 60 divided by the area. Now we're going to take the biggest area. And you are with me that in this question here, the biggest area is 6 square meters. So divided by 6. Remember, this is in newtons, and this one is in meters squared. So my answer here is going to be 10 newtons per square meter. Or someone can say 10 pascals. So you can see when you compare these two answers, the one of 30 and the one of 10, you can see that 30 is greater than 10. Meaning that this 30 here is giving us a maximum value. And this 10 here is giving us a minimum value. So meaning that if you have to calculate the maximum pressure here, make sure that the area is very small. And if you are to calculate the minimum pressure, make sure that the area is bigger. So I'm going to do another example here. Example 2, so that you can understand very well. Because I'm going to leave for you one question, you try it out. So let me first do number 2. Now in question 2, a box of dimensions 20 centimeters by 1 meter by 10 centimeters weighs 30 kilograms. Determine the maximum and minimum pressure exerted by the box on the ground. Now here there's some little trick here. We have a box, and the box they have said it weighs 30 kilograms. Now remember, in physics we work in SI unit. Now the SI unit of weight of force is not a kilogram, meaning that here they have given you the mass of the box. So we have the mass. Now the mass of the box is 30 kgs. But remember that to get the weight will get the mass times gravity, acceleration due to gravity. And on Earth, acceleration due to gravity is always 10 meters per second squared. For O-level students, but those ones in A-level, we use the exact value, which is 9.81. So, our G is 10 meters per second squared. This is a constant. It's the value that will be given to you. So to get our weight or the force, we are going to get the mass, which is 30 times 10, which is in gravity, such that we get 300 newtons. Now this one is the force or the weight. Because they have given us the mass, don't forget that one. What is given in the question is the mass, 30 kilograms. So determine the maximum and minimum pressure that exerts on the ground. We are going to look at the area. Now the area, we are going to determine the smallest area. Now the smallest area, we are going to take the smallest dimensions. And that is 20 centimeters and 10 centimeters. Of course, you know that 1 meter is very big. 1 meter is equivalent to 100 centimeters. So, I'm going to take the smallest as 10, but I'll convert it to meters to SI unit, times 20, also convert it to SI unit. Why have I divided out of 100? Because these are centimeters. And we want to work in SI unit, which is a meter. Therefore, I convert by dividing by 100. And my answer here, I can even try to cross it here. I'm going to get 0.02 square meters. You can even get a calculator and try to divide there. Try to divide 2 divided by 100 there. 0.02 square meters. So, I'm going to get the pressure acting there, which is the maximum pressure. Or I can then first calculate the biggest area. Now the biggest area here is going to be 1 meter. Because 1 meter is going to be 100 centimeters. So I'm going to get 1 meter times 20 something big out of 100. This is going to be 1 times 0.2. My answer is going to be 0.2 square meters. So you can see that these two answers for the area are different. This one is 0.2 square meter. It's very big. It's bigger than 0.02 square meters. Now, I'm going to go ahead and calculate the maximum and minimum pressure. Now, for me to get the pressure max, which we are calling maximum pressure, I'm going to get the force. Our formula is the same, divided by the smallest area, And according to the two answers here, which was the smallest area? Of course, you can see it. 0.02. So I'm going to take that one. So I'm going to get my force, which is 300 divided by 0.02. Okay, you can take out your calculator and try to divide that one. I have 300 divided by 0.02. And the answer there is 15,000. 15,000 newtons per square meter. So this is the maximum pressure. 15,000 newtons per square meter. Or someone can just write 15,000 pascals. So what about the minimum pressure? So minimum pressure now, we are going to consider the biggest area. This is pressure minimum is given by force divided by the biggest area. So the force is the same, which is 300 newtons divided by 0.2. What am I going to get here? Get out your calculator again and try to divide. We are going to have 300 divided by 0.2. And I'm going to get 1,500. So the answer here I'm getting is 1,500 newtons. Or someone can say 1,500 pascals. So as simple as that. So my dear viewer, don't forget that when they ask for pressure, maximum pressure or minimum pressure, look for the area. The area can either be minimum or it can be maximum. Smallest area or biggest area. For example, there is that question there. Because I know you try it out. And they find out, they have given us a cuboid of dimensions 5 centimeters by 10 by 20. And the mass of the cuboid is 6